So here it is, statorless motor number 5. I got it running again. It took a little doing. I had to put a little metal bar on the top to hold the screw straight. The screw was bent, or at least the plastic Lego Technic beam was melted a little around the bolt so the screw would bend, and it wasn't lining up, but now it's going pretty good. And as you can see, I'm going to pan around. You can see there's a little electric plug here, but that's not affecting it. There's a wire rack, a bowl of coins, a Keurig, coffee maker, a stove, a microwave oven in the distance. I don't think any of that is causing interference, but I do want to try it in a different location. If I try it on my kitchen table, I think there might be some interference from the boom box on there with the magnet and the speakers. Metal really doesn't help it. Metal really hurts it. If I hold a piece of metal close to it, it'll make it stop. If I hold a magnet close to it, it will go like crazy. And once again, you'll see the pin bearing and the Phillips head screw, machine screw, makes very little friction and keeps the electricity flowing through there. I think I said 50 watts, maybe it's more like 20 watts, somewhere in that area. I guess it's about a 9 ohm armature and about, let me turn it off, and about 24 volts from the batteries. Here are all the batteries. There's 20 batteries. They're 1.2 volts each. They're NIM batteries, rechargeable. So I guess that's pretty much it. I got it going, and I'm pretty happy with that. You see the little LED there, and under that there's a little photo cell right there. There's a little photo resistor, and that controls the Arduino. Let me turn it back on just so you can see it go. And you'll see that little LED go on and off as the red plastic semicircle covers the photo resistor from the light from the LED. And basically the structure is all made of Legos. It's all Lego Technics. You see the metal bar I put up here has it tends to hold the bolts straight. That's the only reason I put it up there. And let me turn it off again because I think the batteries are really dead. So that's about what I got. I want to try it without the 5/8 inch bolt. This is a 5/8 inch bolt and a nut on the end, and that makes the magnet a lot more powerful, something on the order of like 500 or 5,000 times more powerful, and it adds about 4 times or 5 times the weight. So I think it's worthwhile having that magnetic core in there. But I did want to try it without the bolt in it at one point to see if I could get it to go, because it might just be that it would have enough power with the reduced amount of friction from the weight of the bolt on the bearing. So you can see the L298. Here's the L298, and that gets quite hot at almost 2 amps. And then here's the Arduino with a little proto board on it, a proto shield, and I have some LEDs, and I have everything wired to the Arduino, and I have a little 9-volt battery controlling the Arduino, powering the Arduino. And the sketch is pretty simple. It just turns on the motor in one direction from the motor controller when the light is hitting the photo cell, and it turns the motor in the opposite direction when the light is not hitting the photo cell. And the rest is basically trial and error. Again, it's about 700 or 650 turns on the 26 gauge magnet wire, and running it's about 9 ohms, so I'm putting 24 volts through that, but it's losing at least another 10 ohms in the bearing, and this bearing gets very hot. This whole upper screw gets very hot. The coils get very hot too. So it's really not designed for long use. So, you know, that's what I'm up to. So stay tuned. Hope you enjoyed the video. It's a little shaky. Thank you for watching. Like my video and subscribe to my channel. Thank you.